Welcome to Senior High School Mathematics. Let us have truth tables under General Mathematics Quarter 2 Week 8 based on Curriculum Implementation and Learning Management Matrix for K-12's most essential learning competencies. Here are our learning competencies. Determine the truth values of a compound proposition. Identify tautologies and contradictions. Before we continue, let us ponder on this. Finally, brethren, whatsoever things are true, whatsoever things are honest, whatsoever things are just, whatsoever things are pure, whatsoever things are lovely, whatsoever things are of good report, if there be any virtue, and if there be any praise, think on these things. This is from Philippians chapter 4 verse 8 of the King James Bible. Mathematicians normally use a two-valued logic. Every statement is either true or false. This is called the law of excluded middle. A statement in propositional logic is built from simple statements using the logical connectives, implication, negation, conjunction, and disjunction. The truth or falsity of a statement built with these connectives depends on the truth or falsity of its components. For example, the compound statement, if P, then Q or not R, is built using the logical connectives, implication, disjunction, and negation. The truth or falsity of if P, then Q or not R depends on the truth or falsity of the propositions P, Q, and R. A truth table shows how the truth or falsity of a compound statement depends on the truth or falsity of simple statements from which it is constructed. In the previous presentation, we started to introduce the truth tables by showing the truth tables for the 5 logical operators: implication, negation, conjunction, disjunction, and biconditional. In this presentation, we will construct the truth tables for compound propositions using the long way. That is, constructing columns for each piece of the compound statement and gradually building up to the compound statement. You may be able to develop a different style, and it is fine as long as you show enough work to justify your result. Let us have an example. Let P and Q be propositions. Construct the truth table for the compound proposition P implies Q and Q implies P. Or sometimes we read this as if P then Q and if Q then P. In this proposition, we have two components, P and Q. So we have two propositions P and Q. As we have discussed in the previous presentation, we will have 4 rows. That is, P is true and Q is true on the first row. Second combination, P is true and Q is false. The third one, P is false and Q is true. The last row will have both P and Q as false. Next, as we have mentioned, we will have the compound proposition part by part. Then after P and Q, we will have the first part of the compound proposition, the implication, if P, then Q. This is part of our discussion in the previous presentation that for the conditional if P then Q, this will only be false when the hypothesis or the premise is true and the conclusion or the consequence is false. Hence, this proposition will only be false in the second row, that is P is true, Q is false. Next part, we will have the conditional statement, if Q, then P. Then let us focus our attention at the propositions Q and P. This time, Q is the hypothesis and P is the conclusion. So this will be false when the hypothesis Q is true and the conclusion P is false. And that is in the third row. So Q implies P is false in the third row. Now that we have the conjuncts in our compound proposition, let us have the conjunction if P then Q and if Q then P. Let us now focus our attention in the column P implies Q and the column Q implies P. We know that for the conjunction of two statements, this will only be true when both conjuncts are true or both propositions are true. So the conditional P implies Q and Q implies P are both true in the first row, therefore the conjunction is true. In the second row, P implies Q is false, Q implies P is true, therefore the conjunction is false. In the third row, P implies Q is true, Q implies P is false, then the conjunction is false. In the fourth row, both P implies Q and Q implies P are true, therefore the conjunction is true. Let us have another example. Consider the compound proposition if P implies R and Q implies R, then P or Q implies R. Construct its truth table. So in this compound proposition, we have three propositions P, Q, and R. Then in the arrangement of the truth values, we will have 8 combinations or 8 rows. In the first row, we will have all P, Q, and R true. Second row, P is true, Q is true, R is false. Third row, P is true, Q is false, R is true. And then fourth row, P is true, Q is false, R is false. Notice that in the arrangement, we have all truth values for P as true. Hence, in the next 4 rows, the truth values for P will be false. So next row, we'll have P is false, Q is true, and R is true. Next, P is false, Q is true, R is false. And then P is false, Q is false, R is true. And then in the last row, all P, Q, and R are false. Doing the compound proposition part by part, we will have first the implication P implies R. To have the truth values for P implies R, focus our attention at column P and column R. So for the implication to be false, the hypothesis P must be true and the conclusion R must be false. Hence, in the first row, the implication is true. Second row, false. Hypothesis is true. Conclusion is false. Next, true. Next is false. Next, true. Next, true. True. And then true. For the next part, we will have Q implication R. Now focus our attention at column Q and column R. This time, Q is the hypothesis, R is the conclusion. So for this implication to be false, Q must be true and R must be false. On the first row, this is true. Second row, false. Next, true. Next row, true. Next row, true. And then false. And then true. And then true. Next part, we will have P or Q. Now, focus our attention at column P and column Q. For P or Q to be false, both P and Q must be false. At least one of propositions P and Q is true, the disjunction is true. So first row, this is true. Next, true. True. Next is true. 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 The last two rows will be false. Next part, let us have P implies R and Q implies R. Let us have it represented by S. So for the conjunction to be true, both implications P implies R and Q implies R must be true. Focus our attention in column P implies R and column Q implies R. So first row, this is true. Next, false. True. False, because both of them must be true. And then true. False. True. True. Next, let us have the implication P or Q implies R, and let us have it represented by U. So focus our attention at column P or Q and column R. This is implication. Then for this to be false, P or Q must be true and R false. So first row, this is true. Next, false. True. False. True. False. True. True. And then for the last one, we will have our compound proposition. If P implies R and Q implies R, then P or Q implies R. Focus our attention at column S, that is the conjunction P implies R and Q implies R. Also column U, that is the implication P or Q implies R. So for our compound proposition to be false, S must be true and U must be false. So first we have true, 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 true. So in all rows, the compound proposition is true. That means for any combination of the truth values for propositions P, Q, and R, the compound proposition, if P implies R and Q implies R, then P or Q implies R is true. Example number 3. Let P and Q be propositions. Construct the truth table for the compound proposition P and not Q and P and Q. So in this compound proposition, we have two propositions P and Q. Then in the arrangement of the truth values for P and Q, we will have 4 rows. Next column, let us have the negation of Q. So if Q is true, then the negation of Q is false. And if Q is false, not Q is true. Next column, let us have the conjunction P and not Q. So let us focus our attention at column P and column not Q. For the conjunction to be true, both P and not Q must be true. So we have false, true, false, false. Next, let us have the conjunction P and Q. Focus our attention at column P and column Q. Again, for the conjunction P and Q to be true, both P and Q must be true. First row, this is true. Next, false, false, and then the last row, false. Next, let us have the conjunction P and not Q and P and Q, and let us have it represented by S. So we have S, and then focus our attention in the conjunction P and not Q, also P and Q. So for the compound proposition to be true, both conjuncts must be true. So we have false, 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 false. So that means for whatever combination of truth values for the proposition P and Q, the compound proposition P and not Q and P and Q is false. A proposition that is always true is called a tautology, while a proposition that is always false is called contradiction. We denote the tautologies by the Greek letter tau and contradictions by the Greek letter phi or phi. Hence, example number 2 is a tautology, and example number 3 is a contradiction. A proposition that is neither a tautology nor a contradiction is called a contingency. Notice that in example number 1, in the last column, it shows neither all true nor all false. Hence, example number 1 is an example of a contingency. Let us have another example. Construct the truth table for each of the following propositions and identify whether each is a tautology, a contradiction, or contingency. Letter A, not P and Q and not R. Letter B, P and Q or not P and not Q. Letter C, P implies Q if and only if not Q implies not P. Let us begin with letter A. So we have three propositions, P, Q, and R. So in the arrangement of the combinations for truth values for P, Q, and R, we have 8 rows. After the first three propositions, we start with the negation of P. So if P is true, then the negation of P is false. On the first 4 rows, not P is false. And then on the next 4 rows, since P is false, not P will be true. Next column, we will have the negation of R. So focus our attention at column R. If R is true, then not R is false. So we have first row, not R is false, true, false, true, false, true, false, true. Next column, let us have the conjunction Q and not R, and let us have it represented by S. So for the conjunction to be true, Q must be true and not R must be true. Focus our attention at column Q and column not R. So first row we have true, false, then S is false. True, true, then S is true. False, false, then this is false. False, true, this is false. True, false, S is false. True, true, S is true. False, false, S is false. False, true, S is false. Next, let us have the conjunction not P and Q and not R, and let us have it represented by N. For N to be true, not P must be true, and S, which represents Q and not R, must be true. Let us begin with first row, false, false, this is false. False, true, N is false. False, false. False, false, N is false. True, false. False, true, true, N is true. True, false, N is false. True, false, N is false. So in the last column for the compound proposition, it neither shows all true nor all false. Therefore, this compound proposition is a contingency. Let us proceed to letter B. P and Q, or not P and not Q. So we have two propositions, P and Q. Then we will have 4 rows in the arrangement of the truth values for P and Q. Next column, let us have not P. So if P is true, not P is false. And if P is false, not P is true. Next column, let us have not Q. If Q is true, not Q is false. If Q is false, not Q is true. Next column, let us have Q or not P, and let us have it represented by S. Focus our attention at column Q and column not P. For the disjunction to be true, at least one of the proposition must be true. So the disjunction Q or not P is false in the second row. Next, let us have the column for Q or not P and not Q, and let us have it represented by V. Since this is a conjunction, then for V to be true, the column for Q or not P, represented by S, must be true, and the column for not Q must be true, and that is in the fourth row, so V must be true in the fourth row. Next, let us have the conjunction P and Q or not P and not Q. Have it represented by W. Focus our attention at V, which represents Q or not P and not Q, and also column P. For W to be true, P must be true, and V must be true. So first row, true, false, W is false. Second row, true, false, W is false. Third row, false, false, W is false. Last row, W is false. So for whatever combination of truth values for P and Q, the compound proposition is false. Therefore, this compound proposition is a contradiction. Next, let us proceed to letter C. If P, then Q. If and only if not Q, then not P. Or P implies Q if and only if not Q implies not P. So we have again two simple propositions, P and Q. Then we have 4 rows in the possible combinations. Next row, let us have not P. So if P is true, not P is false. If P is false, not P is true. Next column, let us have not Q. So if Q is true, not Q is false. And if Q is false, not Q is true. Next column, let us have the implication P implies Q. So focus our attention on column P and column Q. P is the hypothesis, Q is the conclusion. Therefore, the implication is false, where P is true and Q is false. That is in the second row. Next, let us have the conditional statement, not Q implies not P, and let us have it represented by V. So in here, the hypothesis is not Q, and the conclusion is not P. So we focus our attention first on column not Q, then on column not P. This is false when not Q is true and not P is false. That is in the second row. So not Q implies not P is false in the second row. Next, let us have the compound proposition. If P, then Q. If and only if not Q implies not P. Let us have it represented by W. On the first row, this is true. Second row, true. Third row, true. Fourth row, true. Hence, P implies Q if and only if not Q implies not P is a tautology. This time, let us have practice exercises. In the practice exercises, you will be given 15 seconds to pause the video and then answer the exercises. Play it again to check whether your answer is correct. Show that the following statements are tautologies by constructing the truth table for each. Letter A. If P implies Q, then not P or Q. Letter B. P implies Q if and only if P and Q. Letter C. P or the negation of P and Q. Let us start with letter A. 15 seconds. Go. Time is up. Let us check your answers. So we have P and Q, and then 4 rows for the combinations of truth values. Next column, let us have the implication P implies Q. So this is false, where P is true and Q is false. Next column, let us have the negation of P. If P is true, then the negation is false. If P is false, then the negation is true. Next column, let us have the disjunction not P or Q. Focus our attention on column not P and column Q. This is false when both not P and Q are false. That is in the second row. So, not P or Q is false only in the second row. Next, let us have if P implies Q, then not P or Q. And let us have it represented by S. So in here, let us focus our attention to P implies Q, and that will be our hypothesis, and not P or Q, and that will be our conclusion. So this is false when the implication P implies Q is true and not P or Q is false, and we do not have that combination in our 4 rows. So for all 4 rows, S is true. Hence, this is a tautology. Let us have letter B. 15 seconds. Go. Thumbs up. Let us check. So we have P and Q, 4 rows for the combinations of the truth values. Next column, let us have P and Q. So P and Q is true when both P and Q has truth value true, and that is in the first row only. Next column, let us have Q if and only if P and Q. So we have the components Q and P and Q. The double implication is true when both components have the same truth values, and that is in the first row, second row, and the fourth row. So the double implication is true in the first, second, and fourth row. Next, let us have V to represent if P, then Q if and only if P and Q. So we have our hypothesis P and the conclusion S, which represents Q if and only if P and Q. So if P is true and S is false, this will be false, and we do not see that in any of the rows. Therefore, V is true for all 4 rows. Hence, this is a tautology. Letter C, go. Time is up, so let us begin with our 4 rows, the combination of the truth values for P and Q. Next row, let us have P and Q. So this is true when both P and Q are true, that is in the first row. Next, the negation of this conjunction. So if P and Q is true, the negation is false. If P and Q is false, the negation is true. Next, let us have the disjunction P or the negation of P and Q, and let us have it represented by S. So for S to be true, at least one of P and the negation of P and Q must be true, and that is seen in all of the rows. Therefore, S is true for all rows. Hence, this is a tautology. That will be all for exercises on this topic. You may download from the link given on the description of this video. Thank you for watching. Please subscribe for more math lessons.